Hi guys, welcome to this page of the notes, and this is our next type of variation function. It's going to be joint variation. I will tell you right in the problem that it is joint variation. I'll tell you y varies jointly as x and z. Again, I can change the variables to anything I want to. In this case, we'll do y, x, and z. So y varies jointly as x and z. I have some non-zero constant, the constant of variation, k. We'll see that in every single one of these. And it winds up looking like this. Y is equal to k, that's my constant of variation, multiplied by x times z. And you can see why it's joint variation, right? I have two variables that I'm multiplying together, x and z, and I multiply that by my constant variation to get y. So joint variation, because now instead of it being just y and x, I'm adding another variable, right? So y varies jointly. It varies based on two other variables, x and z, but k is still the same, that constant of variation. So that's the one formula for joint variation, but the more important one, this one right down here. I think this is the one you guys are going to wind up using most of the time. This is certainly the one that I'm going to use if I give you 2 points. Those points are going to be x1, y1, z1, and x2, y2, and z2. Right, so if I give you this point x, y, z, x1, y1, and z1, I can go ahead and write my joint variation function for that ordered triple. x1, z1, and y1, and then k is my constant variation. I give you a second ordered triple. So let's see, x2, z2, and y2, you plug all that stuff in. But remember, the key here is this. K is the same. It's a constant. It never changes. Doesn't matter what the values of x, y, and z are. K will always be the same. So we solve those guys for k. Since these values are always the same, I can go ahead and set y1 over x1 times z1 equal to y2 over x2 times z2, right? This joint variation equation where I have an initial set of values set equal to a final set of values, and I can do that because they're both going to be equal to k. They both have to be equal to this exact same constant. So this is the one that we will wind up using, I think, most of the time here in the example problems that I'm going to give you, my joint variation function when given an initial and a final set of conditions. x1, y1, and z1, and then an x2, a y2, and a z2. My initial set of conditions, my final set of conditions. You'll be asked to solve for one of them. So let's go ahead and jump into this, see what these look like. All right, so here's what I'm told. First of all, right off the bat, let me highlight it for you. Y varies jointly as x and z. So this is exactly like what I gave you above. So you go, okay, well, I know that it's joint variation, so I know that y is equal to k times x times z. And if I were to solve this for k, k would be equal to y over x times z. So I know right away, if I have an initial set of conditions and a final set of conditions, well, we'll just put in the subscripts. So y1 over x1 times z1 is equal to y2 over x2 times, sorry, that's a terrible 2. That 2 looks like a z, and I don't want to do that to you. Put my little bars on the z's so we don't confuse them with 2. So anyway, all right, so there we go. Initial set of conditions, final set of conditions. All I have to do is figure out what are those conditions. Well, here's what I tell you. I ask you to find y. Find y. When x is equal to 8 and z is equal to 3. Okay, no problem. It doesn't matter whether you make that initial or final. It doesn't matter. You'll get the same answer either way. So I can either make that one the one I don't know, plug in an 8, plug in a 3. Or make this the one that you don't know. It doesn't matter. Plug in the 8, plug in the 3. You'll get the same answer either way. It doesn't matter which one you make the initial set or the final set, because remember, it's all equal to k anyway, right? We have a constant variation. Everybody's got to be equal to k when you use the variation function. So it doesn't matter where you put them. You're going to be solving for either y1 or y2. All right, so here we go. Then I tell you y is 16, z is 2, and x is 5. I do like to make, when I know everybody, the y, the x, and the z, I do like to make that my initial, but that's just my preference. You can do whatever you want. So that's what I'll do. I'll plug in a 16 for y, a 2 for z, and a 5 for x. So let me do that. I have 16 over 5 times 2. That's all going to be equal to, right? That's me plugging in my initial set. 16, y is 16. Z is 2, and x is 5. That's all equal to this final set. I don't know why, so I'll leave the y2, plug in an 8, plug in a 3. y2 over 8 times 3. All right, let's go ahead and do this stuff. I got 16 over 10 is equal to y2 over 8 times 3, right? Yeah, 8 times 3 is 24. Again, I'm dividing by 24 and I gotta solve for y2. This is a pretty easy algebra problem. You just multiply the 24 to the other side. So y2 is equal to 16 over 10 multiplied by 24. Guys, it's plug and chug. Throw that into your calculator. Don't fat finger something. 16 divided by 10, multiply by 24. I get 192 over 5 divided by 5. Sorry, I apologize, I had to squeeze that in. I didn't leave myself very much space here. But anyway, 192 divided by 5, that's as a reduced fraction. That's completely simplified. So there we go. I know thanks to my joint variation function, I can find that y value. Let's go ahead and try another one. Again, please feel free to work ahead. Come on back and check your answers with me. Here's what we've got. I am told that r varies jointly as s and t. Let's write our function first, all right? So I know that r, oh, that's my highlighter marker, r varies jointly. So that means I need a k. You always need a k. And since it's jointly, it'll be multiplied by s multiplied by t. S, t. Solve for k. So k is equal to r over s t. And if I'm given an initial and a final set of conditions, I then know that I'll have r1 over s1 times t1 is equal to r2 over s2 times t2. So there's the guy I'm going to use. Let's go ahead and see what we've been given. I want you to find r. S is 2 and t is 8. All right, no big deal. I'm given an s and a t. Then I'm given 70, s is 10, and t is 4. Let's just start plugging stuff in. All right, r is 70, s is 10, and t is 4. That's all equal to, I don't know r, so we'll leave r2 as a variable. That's all over. S is 2 and t is 8 when s is 2 and t is 8. We'll solve for r2. This is just like the one we did above. I'll have to multiply this guy to the other side. But here we go. Let's simplify a little bit. I got 70 over 40. 2 times 8 is 16. Solve for r2. Multiply the 16 to the other side. 70 divided by 40 multiplied by 16. Plug and chug. Don't fat finger something on your calculator. I get 28. So this value of r has to be 28. All right, guys, so now what we've done is we've taken a look at the direct variation. We've taken a look at joint variation and how you would go about solving problems where you're given an initial set of conditions and asked to find some variable in the final set of conditions. Head on over to the next page of the notes. We have 2 more types of variation to go. We'll look at the next one, and I'll meet you guys there.